Okay, boys and girls, today is a real quick review on domain and range and evaluating functions. It's kind of an extenuation of yesterday. Just going to do a couple off the homework and just kind of call it a day. As far as domain and range goes, domain goes from left to right, so we're looking at the leftmost point, the rightmost point. So from -2 to +4. Now, you got to remember that we either use parentheses or brackets. Anytime we have closed circles like this, we got to use brackets. Same thing for range, so bottom to top, we're going from -1 to +4, bracket and bracket. Now today in class talked about inequality notation as well. Now this just says interval. Want to be sure we're prepared though. So -2 less than or equal to x, less than or equal to 4. Same idea for the range, -1 less than or equal to y, less than or equal to 4. So inequality notation is not what they're asking us for, but I want to be sure that if it's on a quiz, test, ACT, whatever, that you know what's going on with that. Okay, I want to do one that may have a little trickeration involved, number 5. It's got some open circles, got a couple of holes here, all that stuff. Our domain goes from -3 with the parentheses because it's an open circle, and then we have an open circle here, but we have a closed circle, part of the graph right there, so that kind of like makes up for it. Then we go to 4 with a bracket. So inequality notation would be -3 less than this time, x less than or equal to 4. We're never use greater than or greater than or equal to. So don't ever use those when we're dealing domain and range. Unless you have like x is greater than or equal to 4 or something like that. But anyway, when we're doing the inequalities like this, we don't ever use the opposite sign. Okay, and then bottom of top, same idea, -1 to +1. Once again, these points stick up for the holes, so we got -1 to +1 with brackets around it. Next thing here, we got more domain range there. Number 11, we did one like this the other day, and we did a lot of these actually. I'm going to do number 11, and basically anytime you get a rational, we're just looking at the bottom. So what the bottom is, what makes it 0, that's what we can't use. So in this case, we're going to use everything but 0. So the way we say that is -infinity to 0, union 0 to infinity. Or you could say all real numbers except x cannot equal 0. That's the same way of saying the same thing. The next part, got more domain and range, yada yada yada. Piecewise, this is when we take two different pieces of a graph and put it together and it makes one function. I think I have another video on this, but just in case you wanted to just see this one. So -x² plus 4, so we plug in 1 and I'm going to get 3. Now it's an open circle, so I got 1 comma 3 there. Then I plug in 0, then I plug in -1, plug in -2, and I get 0. So I do all that and I get half of the parabola. What do you know? The next thing, for everything bigger than 1, so I put in 1 for x there and I get -1.5. So then I'm going to go up 3, 1, 2, 3, and over 2. Reason why I'm going up 3 is because that's what my slope is. So then I'm going to connect my dots. Boom, 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 boom. Boom. Call it that. And that's my piecewise function. The last thing we're evaluating. So number 20 is a pretty challenging problem. All we're doing is taking a plus k and putting it in for every x, so there and there. Then we're going to take a and subtract it there and there. So I'm going to let you do that one because that one's a lot of fun. For 21, though, just take -1. So I got negative and then -1 squared plus 3. Well, -1 squared, I don't know why I put a parentheses there, my bad. -1 squared is 1, but then I feel like there's a negative sign there, and that makes 2. Alrighty, good luck. See you later.